Hello everyone. Today we'll talk about the solution to the problem maximum swap. In problems like this, where you can swap around digits within a number to create the biggest or the smallest number possible, the main idea is that this is essentially a lexicographical ordering, and in lexicographical orderings, typically the solution is greedy, because when you have some number of digits creating a number, then what you want to do above all is to make sure that the first digit is as big as possible. It's clear why. Because if there was another way to make this first digit be bigger than it is in your solution, then, since the number of digits is constant, the number that that person would get would be better than your number. So you want to maximize this first number, and only if that first number is maximized without you doing anything, or you can do something later, then you can maximize the second number, and so on. So lexicographical ordering typically means greedy, starting from the left, starting from the most important digits. And likewise, it works in this case. Now, you can think about the solution in a way that is fast, maybe linear, that really zooms in at what exactly the single swap should be. But it's also useful, especially if you're programming in Python, where you have multiple tools at your disposal to quickly prototype some maybe not totally dumb, not totally stupid brute force solutions, is to think about some things, start implementing them, and at some point you can just generate all the options and select the best options from among all the options that you generated. This works especially for simple tasks. And thus, this will be the solution that I'm going to show you today, that uses one observation and then uses just, instead of thinking about what the best option is a priori, it'll just generate all the options and select the best one, once we have narrowed down the space of possibilities. Because of course the space of possibilities for any swap of two digits, it is quadratic with respect to the number of digits in our number, and this will pass in this case because our numbers are integers. However, this problem also makes sense for numbers that have very many digits, for big nums. In that case, we should not use a quadratic solution, but an n log n solution should work. Well, of course, my solution here will not be really n log n, but that's because if we have big numbers, and many big numbers, then of course working on them might be too difficult. But this is just a proof of concept, just to show you this approach that often is the best and most convenient approach. Anyway, let's get to the code. We'll be operating on lists of characters instead of numbers, because we want to be able to swap them around, and strings are immutable, and to swap two digits within an integer is something that requires a little bit of math. It's not difficult, but it's probably easier to just perform a normal swap on a list. And the first thing to do is we want to see the first position where our swap will certainly take place. This is the part where we use the greedy concerning lexicographical ordering. So, to see that place, the first place that we should swap easily, we can use this trick. We can just sort all the digits within our number in descending order. So this is the absolute biggest number that we can get using any number of swaps. And now, certainly, as long as our number matches the biggest possible number on positions from the left, we don't want to touch those positions. They are already the biggest that they can be. So we'll have to find the first position that differs between our original number and the biggest possible number. So we do that with a simple while loop. If at the end there is no such position, that means that our number is already the biggest possible number, so we can just return it. Otherwise, I holds the first position where the biggest number and the number that we're given differs. So any single swap that we do will always swap at this exact position with some other place. And now, instead of thinking, okay, what other position should we swap with this position, we can just generate the whole linear number of swaps at this point. So we'll generate all the options by swapping for j, going through all the possible positions. We swap j and I, the positions j and I, and swap them back later. And between those two swaps, we append the resulting number to our options. So now our options has the number of numbers that's about the same, so it's linear with respect to the number of digits in our number. And the maximum within this opts list is the biggest number that we can acquire using a single swap, which is exactly what we want to give in this problem.